relative maxima and relative minima of functions, of their graphs. Our objective for this video, we want to use the graphs of functions to locate relative, also called local, maxima and minima. Maxima is plural for a relative maximum, and minima is also plural for minimum. Okay? So what do we know that's going to help us here? We know what a function is. A relation in which each component of the domain, each input value, each x value, corresponds to or is mapped to exactly one component of the range, or output value, or y value. Okay, when we deal with function graphs, of course, if it's a linear function, it's simply a straight line. But if it's not a linear function, and linear function is just one kind of function. If it's not linear, then it can have hills and valleys as it goes along, okay? So the graphs of function can have hills and valleys. Now remember, it still has to pass the vertical line test, so all vertical lines can only touch the graph in one place for it to be a function. And these hills and valleys are places where the graph can reach a minimum or a maximum value locally, okay? Right in that little area. And here's a graph of some unnamed function called f of x. And you can see I have a local maximum right here, or a relative maximum. It's relative to the immediate vicinity. It's a hilltop relative to what's very close around it. I have a relative or a local maximum here and here, and I have a local minimum here. Again, this low point is relative to what's right around it. Obviously, it's lower over here, and it's lower over here, but this is local. It's relative to an area around it. Okay, so to define these relative or local maxima or minima, you first choose an interval around it. And we're just going to kind of draw a basic interval around it. Then, if the height of the function at a, for example, is greater than the height anywhere else in that interval, then there is a local maximum at x of a whose value is f of a, the value of the function at a, okay, which is the y value. Similarly, if I got that pronounced correctly, if the height of the function at b, okay, is less than the height anywhere else in the interval, then there is a local minimum at x equals b, whose value is f of b, okay? So if I go to this one, I can just define an interval. So I'll define an interval from here to here. Okay, I defined an interval. Well, this is x equals a, so I'll come down here and I'll say that this is a. Okay, and I just defined an interval, and at x equals a, I have a maximum. Okay, so where is that maximum? The maximum is at x equals a. What is that maximum? Well, I would go over to here, the value of f of a, and that would tell you what the maximum is. This is the where, and this is the what. Where is the local maximum? X equals a. What is the local maximum? The value of the function at a. And similarly, I'm going to call this local minimum. I'm going to define this local minimum. I'll just use a couple of lines like this. Okay, there's my interval around, and that one's b. Okay, and in this interval, at x equals b, I have a low place. Okay, I have a minimum. Okay, where is it located? At x equals b. What is its value? Well, I would go over to here, and I would find the value of f of b right there to come up with what it is. So what is the y value? Where is the x value? Important to keep that straight. Okay, let's take a look at an example. Okay, so I've got the graph of a function f below. If you want me to label it, I will. There's my f function. Use the graph to find the values, the x values at which, where f has a relative maximum or minimum, and what these relative maximum and minimum are. So what, this is the where, okay, to find at which, where, and this is the what, that's the y values, okay? Okay, so where do I have a relative minimum? Well, I'll go from left to right. I'll just define an interval. There's an interval right there, and I have a minimum right here. Okay, so I have a relative minimum, M-I-N-I-M, at x equals -1. I just defined an interval, and at x equals -1, I have a minimum within that interval. Okay. The relative minimum, well, what is that minimum? The value, the relative minimum, at x equals -1, well, it turns out it is. Okay, so if I come down, there's where it's located, and this is what it is. It is -1. Okay, so I have a relative minimum at x equals -1. That's where it's located. What is that minimum? The relative minimum at x equals -1 is the same. It's also -1 on the y-axis. Okay, let's work our way from left to right. I'll draw an interval from here to here, and I can see I have a maximum in that interval right here. So I have a relative max at x equals 0. Okay, relative max is at x equals 0. What is that relative max? Another way to say it, the value, that's probably not what I want to say. I probably won't say the value. Oh, I can use the word value. The value of the relative max is also 0. Okay? Okay, so where is it located? X equals 0. What is its value? It's also 0. The value of this max is the y-coordinate, the 0. Okay, one more. Again, I'll draw an interval around it because I have another low point, a local or relative low point here. Okay, so I have a relative min at x equals +1. This is 1 here. Okay, and what is the value? What is the value of this particular relative min? What is it? The value of this relative min, well, the value is, it's -1. Okay, is -1. Okay, so the key, okay, you locate it with your x values and you indicate what it is with the y values when you're looking at relative maxima and minima of functions.